In this precalculus algebra video, we're going to graph the function f of x equals 1 over x. And we're going to do that by creating a table of points or table of values and make some observations about this graph. So we're going to let first x be 3. And when x is 3, we get 3 for x, and it's 1 over 3 for y. And when x is 2, we likewise get 1/2. When x is 1, we get, well, 1 over 1, which is 1. Okay, when x is 1/2, what do we get? Well, we get f of 1/2, which is 1 over 1/2. Now, whenever you take something and you divide by a fraction, that's the same as taking the numerator and multiplying by the reciprocal. And the reciprocal of 1/2 is 2. So we end up getting 2. So when you plug in 1/2, you get 2. And likewise, when you plug in 1/3, you're going to get 3. So let's plot those values. 3 1/3, 2 1/2, and so on. So 3 1/3 would be about here. 2 1/2 maybe there, 1 1 maybe here, 1/2 2 up here, and then 1/3 3 maybe there. And so what we're seeing is that we're creating this curve, this branch of the function. Let's go ahead and draw that in now. And that would be the graph. So let's make an observation. We notice that if you're going this way, as x is getting smaller, what's y doing? Well, the y-coordinate's getting bigger. So we're going to write down that as x goes to 0, this little arrow means goes to, so x is heading to 0. The y-coordinate is going to infinity. It's getting bigger. As x goes to 0, y is going to infinity. Let's ask ourselves what's happening over here. So we'll create a table of values, but for x being negative. Let's do the same thing. But now we'll have x be negative. So let's take in, for example, -3, or plug in rather -3. And we get -1/3, right? When we plug in -3 here, you plug in -2, you get -1/2. You plug in -1, you get -1. You plug in -1/2, and you get -2 for the same reasons as before. When you plug in -1/3, we're going to get -3. And when we plot those values, let's see, -3, -1/3, -2, -1/2, -1, -1, -1/2, -2, maybe right there, -1/3, -3 down here. We're getting this branch. Okay, let's graph that in now. And that gives us the second branch. And now what's happening as x goes to 0? Well, from this side, as x goes to 0, y is going to -infinity. And that suggests that maybe this notation that we had earlier was a little bit problematic, or rather ambiguous. Because here, isn't x going to 0 when you're a little bit bigger than 0? Like all the values of x are a little bit bigger than 0. So put a little plus sign to tell us that we're approaching 0 from the right of 0 on the number line. So here's 0, and we're coming in from the right of 0. And that means, for this other situation, that we're approaching 0 not from the right, but from the left of 0. So from numbers that are a little bit less than 0. So we're coming in like this, and what's y doing? Well, y is not going to positive infinity, y is going to -infinity in that case. And we can make a couple of other observations. As x goes to infinity, what's y doing? Well, isn't y going to 0? Let's write that down. As x gets larger, as x goes to infinity, the y is getting smaller and smaller, heading to 0. And likewise, what about x going to -infinity, coming out this way? Well, as x approaches -infinity, we end up seeing that y is getting closer to 0 as well. Okay, so one more observation to make. Now, when we had this first case, when x was going to 0 from the right, and y was going to infinity, what's basically happening? Well, the denominator is getting smaller and smaller, right? The denominator is heading to 0, but the numerator is not changing. The numerator is remaining 1. So we're noticing that this fraction gets big, that is, y is going to infinity, when the denominator goes to 0. Not the numerator getting large, but the denominator going to 0. Let's write that down. That fractions can get big when the denominator goes to 0. Okay, and that's kind of the main point of this video, is to illustrate that. It's going to be really important for us that there are two ways a fraction can get big. One way, as you know, is the numerator can get large. But the second way, the more subtle way, is that the numerator can stay the same, and if the denominator goes to 0, then the whole fraction can blow up. The whole fraction can go to infinity. Okay? And that's really the main important point to take away from this lesson. Okay, and we'll be using that fact later on in calculus as well. Until next time.